Hi, my name is Allison.
Hi, my name is Jessie.
And we're both here with the first alumni of UW-Madison. This morning when we were starting off our adventure through Robot in 3 days, we started off by looking at the game manual, which was released during the broadcast. We started off by looking at the game manual in order to make sure that we fully understood the scope of the game and really what the points were, where we can score, where we can't, and what rule violations will be critical to watch out for. To do that, we kind of went through the game manual and pulled out really key point values of what game pieces we can score and where. We also studied some of the important rules violations that we would have to be aware of in order to make sure that we didn't end up getting our team multiple major tech fouls. We also went through the game manual to pull out really key measurements, including the height of different parts of the reef, the height of the barge, and the height of the processor. All of these measurements help us design our robot going forward. After we pulled out the really key strategies that we were able to find in the game manual, we progressed to setting some goals to make sure that in our 3 days we made the most out of all of our time.
Our goals comes in 3 different levels. On level 1, we're thinking about things we will be able to achieve, including basic functionalities like drive, auto leave, and park. Also, scoring on level 1, 2, and 3, algae processors and ground intake. Level 2, we're thinking about things we're considered to be able to achieve, and we hope we will be able to achieve, including scoring at L4 and throw algae into the barge. Level 3, there's things we don't think we want to reach for. That will be, we're not trying to go for any cage point, which means we're not planning on to have our robot climb up the cage. After setting some of our goals, we progressed into brainstorming.
Hi, I'm Will.
And I'm Carly, and we're with the first alumni of UW-Madison. So next we've moved on to the brainstorming stage of our design, and the first thing we started thinking about was the drivetrain. So this one was kind of pre-selected for us because we went with tank drive, that being the most simple and easiest to program. We also thought about different drivetrains and noted that swerve drive would probably be the most effective to be competitive because of its wide range of motion and ease of maneuverability on the field.
The next mechanism we went over was sort of an extension mechanism because we realized we needed to reach high to reach both the L2 and the L3, possibly even the L4. To do that, we came up with 2 mechanism ideas, one being an arm and the second being an elevator. The arm ended up winning this debate because we simply do not have the parts to build an elevator, but it also comes with the advantage of being a much simpler mechanism and a little bit easier to design and work with. All right, moving on to intake, we came up with 2 prototypes, one being a passive mechanism, one being an active mechanism.
Yeah, so for the passive one, this one is extremely simple. The whole point of it was originally to go into the coral when it's laying on its side and be able to pick it up, swing upwards, and then drop it off on the reef vertically. Now, we added a second prong to it in order to be able to also pick up the ball, and this way it'd be able to manipulate and hopefully go up and down high enough to drop it off at the processor. And with enough range of motion in the arm or mechanism behind the end effector itself, this would hopefully be able to score up pretty high, possibly on L2 or 3, maybe even 4, depending on how high the arm can take it.
As for the active mechanism, here we have 2 different parts. We have one main section for the ball, and that shares a compliant wheel with the intake mechanism for the pipe. So if we could just run that real quick. So as you can see, we can pretty easily intake one of these big algae balls and outtake. And then as for the coral, we have a second smaller compliant wheel on the bottom to help with intaking and outtaking. And those are our 2 designs. That's all for today, guys. Be sure to check us out on First Updates Now, first alumni of UW-Madison, for future build updates. Good luck roboting.